In question 5, we have something which happens quite often in chemistry. And what that means is that we run a reaction that maybe we intended to do one thing, yet we end up finding that something different occurs. And so often at that point, we want to find an explanation for what happened, what went wrong, or why did it go differently from what we expected. So in order to do that, we would normally start by following this mechanism exactly the way we would expect it to go. And so if this is an aldol condensation or a variant of, then we would expect that we would start by removing the alpha hydrogen and making an enolate. And then that enolate would do nucleophilic attack onto the carbonyl. And so if we follow our logic that this is a variant of the aldol condensation, then so far we've done everything that an aldol condensation would normally do. But here is where something could go differently. Because normally, if this was going to be an aldol condensation, that O- that we just made would protonate, and then we would go through the elimination to get the alkene. But right here in the molecule, we have something we've seen before. It's an O-, an oxygen anion, right next to a halogen. In fact, you might recall that a long time ago, back in Organic 1, we had actually said that this type of functionality was an alternative way to make an epoxide. And so if this oxygen, this anion, is able to attack the neighboring atom, the chlorine, it can do this because the chlorine there is a leaving group. It kicks out the chlorine, and we end up with the product that was observed.